Hello, welcome to this office hours. This office hours number 2. We'll be going over several things, more specifically units 2 and 3, and then have time for Q&A. So if we just go over like a theory level of, so here's social media survivable, et cetera, et cetera, et cetera. So today, yeah, we're gonna go over units 2, 3, and then have some time for Q&A right here. So let's start with unit 2. Let's just jump right in. So we're going to start with talking about objects. So an object is a specific instance of a class, meaning like an object is, so if we have a class called balls, right? Then a basketball is an object of the class balls because it is a type. It is a specific class, like a specific time where it follows where it's like under the class balls. And so this, a class is like a formal implementation or like a blueprint which has like attributes and behaviors of an object, like a ball bounces, right? And so that's why there's a class balls, because it has these characteristics of balls, like they're round, they're spheres, right? They bounce, right? They all have these different things, and so that's what makes it a class. And then we have specific instances or objects underneath that class. And so that's what an object is. It's like a specific time we're under a class, which is like a framework of something. It's a specific time, like a specific thing of under that class. And so why do we create and store objects? And so Java is a type of programming language called object-oriented programming, or we do the programming and it's orienting all around the objects. It's about a specific object. And so when we create and store these objects, right, we create them the same. So we have to create a constructor in the specific class. So like if you look at BlueJ here, I have my class main, but I can create a new class and call it, yes, balls, right? And so now in here, we have like our basketball and stuff. And so at the start of each class, we have to make a constructor. The constructor is what creates the specific object. It tells us like, that's where we code how you create it. And so there are different types of constructors, right? There are, the name's wording losing me, but we have constructors that are like default, and then we have like constructors that are like actual constructors. And so like they construct the object, right? So if I pull up an older project here, so let's look at TOS, this might have one. No, this does not have any project here that has more than one class. This one might have one. Yeah, so this has 3 classes. We have array list, dictionary, and main. So if I just open the dictionary class, we start with a constructor. And so we start with constructors. Now this is not actually a bad example. I have a constructor here. Let me pull up an example. Gizmo, do you have one? No, I don't. Array list might have one. Right, and so right here is our constructor. Right here, public array list. That's just our constructor, because that is just creating an array list. That is our constructor that creates the thing. That's what we need to create an instance of the constructor. Now we just have to call an array list in the other classes, and that's it. We have an array list. So if I do this, the main relies on the dictionary, which relies on the array list. These are different classes, and so the main class uses things from there, and we have different lines. And so right here, new dictionary, this right here is a new dictionary. This is using our constructor from the dictionary class. Where is our constructor in the dictionary class? Let me find it. Oh wait, no, because we're using an array list. So there's no constructor here. I see. So yeah, so here we have it, we've created, this is how we create it. So in the other classes, like here, new array list, public array list words. We are here creating an object called words that is the class array list. And so when this happens, it goes to this constructor here. And if we can have specific instructions for here we don't need it because an array list is like a known class, et cetera, or it's not like a known class, but like it's like something that we use and we know day to day. All right, and so yeah, right here, we don't need any parameters to create an array list, and sometimes we might. So here, looking at our main, right, we don't have any things to pass to the dictionary. There are no things that when we create a dictionary that we need to know. So we don't pass any parameters into it. Right? And so constructors, there are two types of constructors. They're regular constructors and they're overloaded constructors. And so an overloaded constructor is something that happens when there's multiple constructors with the same name, but they all require something different. Like they all have different parameters. And so those loaded constructors. And that's something that like will be like a gotcha on the test. And so that's something you need to look out for during the AP exam. And so yeah, when you pass the parameters, they have to be be compatible with what's asked. Okay. And now we have void, right? But before, we also have another thing. We need to know about null. Why is null important? So if you were to ask someone what null is, someone might say it's nothing, it's zero, it's empty. What it means is that there's nothing associated. Like it's a blank space. Like it doesn't mean zero, because zero is still like an integer. Right? It means like there's just nothing at all. Like it's a blank space. There's nothing associated with it. And so this is there that, in your code, when you code things, you'll have to add things like null checks. So that if someone puts like a null into like the parameters that come in, like here, when we start, we have an array of strings called arguments. But if someone puts nothing in there and they put in with null, we have to have a null check for depending on your code. Here we don't need because we're adding more things to it. But in some cases, we need to add null checks to make sure that if people add null, we don't break our code. And so that's why null is important. Null is also used like, to put nothing at all. All right, next, we have void. So what's a void method? Right here, we can see public static void main blank, and then here's our arguments. We have void. This is a void method. And so what this means is that we do not expect, we don't want this different individual method to give us anything in return. It can print things, yes, but it's not gonna return some value. And that's a void method. So a void method might be something like void methods are like your main at the end, because it's still gonna be printing and doing stuff, but we don't want it to return an object and then come, right? We want it to print things, but we don't want it to do a return. Like if I put a return command in here, it'd give me an error. Like, return 1. Can I do it? Oh no, okay. Like if I do new int pi equals 3. Oh no, it's 3, right? And if I do return pi, it's gonna give me an error because, oh, wait, no, I need to get my semicolon. Right here, it's giving me an error because it doesn't expect to return a value, right? And so it's void. And so if we were to make this an int, however, we expect this to return an int, which is this, so an int, a string, a double, these are all non-void methods. And so if we did this, we're good. If I did take this out, it's gonna give me an error because, it finds better errors that it doesn't like, but it would give me an error because it expects me to, when I run that thing, it's gonna expect me to return an int, but I never did. I never returned the int. And so it'd give me an error. So we have to identify what is going to be returned by this individual method. And so this gets useful later on when we're relying on multiple methods to do multiple things. Like if you have 100 different numbers and you have to, if you have 100 different foods and you have to do something to it, and you're going to create a method to do that for those 100 words, that's why this is important, because we know what we need to do, right? And so, yes, this is why we use different kinds of methods, because we need to know what to return. Now, what are our different kinds of methods, right? We have strings, we can even make it a specific object. We can make it an int, we can make it a double. There can be an infinite amount because we can create as many objects as we want. We can create a pizza class, a pizza object. We could create a spoon object. We could create a speaker object. We could create a Fitbit. We could create an iPhone. We could go individual iPhones if we want to. So we can create an infinite amount. It's just that we need to identify what is going to be returned. So now let's talk about strings. So a string, as you can see right here, string is an object. So when we write something type string, we make it capital right there, and then it could be an array, as in this case, it doesn't have to be an array. And so strings can be concatenated by using the plus or the plus equals. We can concatenate strings together, creating a new string object. The string methods do not change the string object. Now, that means the string objects are immutable. You can't change them. And yeah, and so yeah, you use this right here is where when we create a string, like string blank equals blank, we're using the string constructor to create a string, or a blank equals new string. Yeah, so permanent values can be created strings, escapes. So then we have different types of escape sequences. So like if you want to add a tab, how do you do it? Or if you want to create a new line. And so that's what we use the slash for. So if I were to do, like we have slash this, right? And that's how we can make quotes within the string. Because if otherwise we're just gonna have, like, it's gonna think, oh, we're doing quotes. These are also known as string literals. We can do slash slash, slash n. We can do all these different things to add things like quotes and different things that otherwise would give us an error, like a tab or a new line, which is okay. We also have string methods. So string methods, so string class is part of the java.length package, which is the normal. A string object has the index values from 0 to length -1. Remember, so if we ever need the length, if we go anything further, we'll get the index out of bounds exception or error. A string object can be concatenated, which just calls like the toString method, right? What else do we know? So the different string methods you need to know, right? String to create a new string, right? Int length, string substring to go from here to here, like to get the string, and we start from what letter to the letter, and we get that individual string, right? We do substring, right? We also do substring from blank here to here to here. But this is just another way to write it out. We have the index of, and then we can put a letter or a string, right? And the first time this specific thing is found, it gives us the index of it. Like each letter has an index going from 0 to length -1. We have equals to see if the strings are the same, and it's a Boolean type, so that returns true or false. And then we have compared to, that returns less than 0 if it's less than the other, 0 if they're equal, or greater than 0 if they're longer. Right, and then we have our next type of class. These are also known as the wrapper classes. These are integers and doubles, which we already know, right? And so, these are integers, integer values, integer.min, integer.max value, int value returns like the integer of this integer as an int. Because integer and int are two different things. They have two different variables. It's the same way with array and array list. They all have different functionalities, and we can convert them to each other. It is like, using int value, we can return the value of an integer as an int. An int is not the same thing as an integer. Right? For doubles, we have the same thing. In doubles, they're specified with capital D for that, or in the lowercase d for the wrapper being with a capital D. And so with doubles, there are no specific things. Like with integers, we have max and min values. We just have creating a double and turning the double into a double. Okay, and now we have the math class. And so the math is also part of java.lang. The math class only has static operators. And so static methods are called static methods. And they're only called right here. This is a static method. That means we can use the dot operator and call it along with the class name, unless we are defined within the closing class. So we can use them outside of classes using the dot operator, right? And non-static within their class. And so with the math class, we get an absolute value. We have we also have, we can do bases and exponents, right? We have square roots, and we can get random values. And that's something that we will see math.random. That's something you will use 100% in the AP exam. Okay, and so that's everything for Unit 2. Now we can go to Unit 3. And so Unit 3 is a lot more, more about Boolean if statements with logic within your code. So, start. What is a Boolean so what is a Boolean expression? A Boolean expression is like a true or, it's a true or false, right? That's a Boolean, but a Boolean expression is where we're using that. And so we have things like equals equals, where it's set equal to, like we're comparing the values, or exclamation equals, where we're checking, are these not equal to each other? Or we have greater than, less than. These are all Boolean expressions because we return a true or false. So if I were to do if, let's go to this class, right? We go to main because we don't need the boss class, right? We do public static void main, right? I'm just going to do this. Why is he not with me? Oh, class. Public class main. All right, so we have our main method here. And so let's say we did int 1 equals 1 and 2 equals 1. If 1, oh wait, I'm going to make this 2. If 1 equals 2, system.out.println Right. So if we compile this and quickly run it, it prints out hello because they're equal. But if we make this 2, right, it's not going to print out anything because they're not equal to each other. But if we change it here, we're making sure that they're not equal to. And we compile and we run it, we get a hello. This hello is from before the first one because it doesn't wipe within per run. So that's a Boolean expression. And so here we also use an if statement, saying that if this one situation is true, or if this is true, then we do the code underneath. And we can have multiple if statements, right? And those are called, like I could put another if in here. If right? So that means that if this one situation happens, we print this, and now we're within this, and then we check another situation. So this is a nested statement, right? And so we also have if-else statements. So let's say go here, if else, and then we can put another thing. So it looks here, and it says, okay, let's click here. Right, so this is so if else is a bit complex. Like I personally never used an if else statement at all last year, but it's like where so an if the way it's like the way College Board talks is different. If else is different. So we now have an else. So it goes here. So and we use an else, not yeah. So we have else, yeah. Else you use a lot. So we look here and we go here and we go to the if. And it sees, does this happen? No. In this case, it does happen. So we skip it. But if we make this equal to each other, and we do this, what's gonna print is this will never print because this is not true. It skipped this and it went to else. We can also go else if. We can put we'll put our condition right here, which will be right. And what it does is it goes here. It goes if this, but this is not true, and it checks this. Else if blank, and then right, and it says, oh, this is true. Then it skips the else because we did a condition. All right, let's go here. Yeah. Other than that. Yeah, we have another thing is we can go 1, this 2, and we can do this, and we can go 1 equals 2. Now in this case, this else if never goes through because yes, this is true, but this means and. So we're saying this occurs and this is true. Now in this case, this is not true, so this never happens. But we could also do this, which means or. So if this or this is true, we do the inside thing. And so these are different things to like, expand, so we don't have to create nested things, or we don't have to duplicate if or else statements. Like what happens. Next. All right. Comparing compound expressions. So a compound, yeah, so these are also called compound expressions, where we have one or two or this and this. Equivalent, yeah, so other than that, we also have comparing objects. So let's say objects can be compared using equals equals or exclamation mark equals to see if they're the sum. Reference value can be compared with null using equals equals or plus equal to see if it's actually null. And that's what we use null check. So we can take things and compare it to null. So if we can go and say if 1 equals null, right? Well, how it won't work is this is a null list. But if we made this an object, right? We can't do it because I didn't create a whole new class creating an object and all that. But if this was like a ball, right? A ball 1 equals this, right? We didn't create, oh, this is balls, right? So if we create it, we don't have the constructor and makes an issue, right? We have to, make sure it is there. But also good because we didn't compile. Yeah, like we didn't create public class, public. Compile. You like it now? Okay, yeah. So like we have to create the constructor, we have to identify it and all that. We haven't done that here. But that allows us to, we can check, is it equal to each other? Our classes also can have their own equals, like a dot equals to methods and all that. We can use to compare also. So, oh, we've got a question in chat. So void would not be used for scanner classes. Okay, so let's go to my example here, where we use the scanner. Right here, I use the scanner, right? We're using, so what void is for returning things. We can still print things out but return them. So for example, right here, where's a good example, right? We have this public int size method, right? And so in the dictionary class, if I were to run, right? If I was to run something called, like right here, so here we're calling that class. Of course I didn't, yeah, right? Or here, let me just do that. Here we're calling we're calling the dot size method here. And so what happens is we're saying, I want you to get the size of this thing and then replace this with that value, okay? So what happens is it goes here, it does the command, it does the code to get the size, right? Right, so now we have our size, which is a stored count, and we return it because it's an int. What we're doing is we're getting how long it is, this object, like this, right, this is an array list. We return that, and because it's an int, we return it. And so what that does is it makes, right, because this is an int, it's like a double check, because we can't make a string an integer. Or we can, but that gets a lot more complex. We can cast a string as an integer. We can do all that, but in this case, this is not where we're doing that. Here, we are expecting an int, right? And so what happens is we're expecting an int, and we're going to give them, we want this to come back as an int. So what happens is we put in our value, we get an int right here. We're expecting an int. We have our int, and that int value goes all the way back, and that replaces this value, which then goes back and goes here when we do the dot size command. So what it is a void is where we're not expecting to return anything. So if we run a command that does something internal, like stores something of this, for example, if you're on the Fireball website and you break the page somehow, right? And that will give our developers an error, right? So what happens is we don't want the error to come to you. We want them to get the error because then they know, okay, this is something we need to fix, all right, et cetera, et cetera, et cetera. So what we do is we have that method that does it in a void because we don't want anything to go to you, but we still want something to happen internally. And so that's what a void is. It's where we don't something to get returned. We can have still stuff print like, oh, we're sorry, we had an error here, or something like that, but we don't want it to like return, like we don't want it to return to you. We want to do something on our end. We still can print stuff, but it's like, if you, like, this is where this comes into play when we're using multiple commands, or not commands, multiple methods. Because if we have a different method that says int, right, that means we're going to use that method within other methods. And so we want whatever is going to be returned to them being an int. So like the void and a scanner class are two separate things. They don't combine. Okay. So now we have Q&A. If anyone else has any more questions. Was that able to help you with void or scanner, or should I clarify it in a different way?
I had a question on unit 4. Could I ask that?
Wait. Oh, wait. Paul B, can you try again? I could not hear this whole time.
I said I had a question on unit 4. Would I be
Okay.
able to ask about that?
You can ask that. Yeah.
Okay. I was wondering how I'd be able to make like a nested loop that would be able to take out all the repeated like letters.
So like nested okay, so can you give me like a specific example? Like, so let's say we had the word pizza and we wanted to take the Z's out of it, all the Z's, or if we had a long string and we wanted to take all the vowels out of it. Are you talking like that?
Yeah, something like that.
Okay.
Because I've been trying to do it and it'll take out the repeated word, like we'll take out the repeated letters, but only in one word. And then the next word will have the same, like if it says hello world, it'll only take out the second L in hello, but it won't do it for world.
Okay, so when we say we're moving letters, so we're moving all the L's in hello world, for example? Or just specific L's?
Yeah.
Wait, specific
it's
or
all the repeated words.
All the repeated letters.
It's all
so we take out all the L's, right? From both words or just one?
It would be, well,
right,
we'd still have one L.
So if I had hello world, right? Right, we have hello world. Let me share my screen. I'm not sharing. Boom, boom. Okay, so we have hello world. Hello world, right? Are we expecting hello word? What is that? What we're expecting?
Yeah.
Okay. So is this one string or two strings? Two separate strings?
It's one string.
Okay. So what we can do is we can make it that if we could code it. I'm just gonna give a theory base because this sounds like it's like I don't want to like give you the answer like straight away. Like I still want you like to figure it out, try and like I'm gonna give you some direction, but I'm not gonna like answer it fully for you. But what we want to do, like I'm gonna give you some like theory, like what we want to do as a question is what we want to do is we want to. In this case, we would probably use a while, and what we would do is while it identifies each letter, we make a count. Right? This is like how I would do it. There's more than one way of doing this. This is the way I would do it. What I would do is I'd make a count, right? And each time it identifies a specific letter. Like I found H, right? And we make a count H and we make it 1. And we found an E, we make that count 2, right? There are different ways of doing this. There'll be simpler ways, there'll be complex ways, right? And what we'll do is we can make the L, right? And we get an L and we get an L, right? And so now once we pass the second L, our count has become 2 for that L. And so what we'll do is we'll move that L, all right? And what we'll do is we'll start from the top again because we don't want to skip letters later on. And we'll do it again, right? And so what happens is it finds this O right here and it will remove it because O's count became 2. right? And we can do the same, and then it'll go again, find L, L's count will become 2. And so what does it do? It removes the L, the second L. Another way to do it is have it do all the counting at the start, right? And so what happens is it gets a count of O being 2 and L being 3. And what it does is it finds the latest L's substrings and like getting the index up, and it finds the later L's in the thing, and it removes those using like the index. So those are 2 ways, theory-based, you can solve it. There are probably simpler ways that are like, you don't have to use count. There are probably simpler ways, but these are like the first ways that are initially coming to mind. All right, and then what do we have? Okay, so if you use import.java.util, would you use void or? Okay, so you wouldn't, most of the time the laying class is already in. That's just like basic background info. You wouldn't necessarily need to bring in the laying class. Next. What are the type of short response questions in the AP CSA exams? So far, according to College Board, it's going to be the normal CSA. It's not going to be the all last year's CSA where we only had 2 questions. It's going to be all 4 questions. Let me pull up the questions, what they are exactly, because we know College Board has told us, like they tell us every year, what the question types will be. Give me a sec. Let me find it. Right, so on the first response, we have 4 questions. Here we go. Okay, so yes, we have 4 questions. The first question will be on methods and control structures. So be able to create objects of a class and call methods, be able to satisfy method specifications using expressions, conditional statements, and iterative statements. Question 2 is focused on classes. So, creating a new class, creating constructors, all that stuff. Question 3 is going to be on arrays or array lists, so creating an array, doing stuff to that array. So questions 1 and 3 were the ones on last year's AP exam. And then question 4 will be doing stuff with 2D arrays. So those are what the free response questions are on. And then, so if you would use java.import.util.java, what would you use? So right here, we're importing java.util.scanner. We don't need to use void. Void is for a method. Like this is here a method because it's the add method. When we're importing like java.util.something, like util.java. Right, or java.util. Whatever it is, you wouldn't use void because this is not a situation where you need to do it. Right? That's just an import command. You wouldn't use the laying class because the laying class is already there in the first place. Laying class is just like all the stuff, like an int and all the stuff, it has to have a class. That's called the laying class. That's already implemented. You don't need to call that class in or anything. All right. Are there any other questions?
Do you think I would be able to share my screen to show you?
Yeah. I don't. Let me see if you can you. Try. I'm not sure if you.
Yeah, I think it's letting me.
Okay, go ahead.
Okay, so for this one.
Yeah. Okay. So we have your code.
It's right here.
Okay. So yeah, you did a unique thing. Right. Okay. So what is it doing? Okay, else if this and this equals to blank, j minus 1, unique plus plus. Okay.
So right now, this one, it takes it out if there's repeated, but in only one word. And I even tried doing this. So I take out every space. Like I tried combining.
I don't think it's one word. I think it's doing is it's looking if they're next to each other.
Oh.
You're comparing the letters, like the one letter and the letter after it. You're comparing those 2 letters. And so because there's an L later on, you're not removing it.
Oh, so I need to do it.
Yeah, so what you're doing is right now, let's say this. So if I have, right, so if I have a letter, right, these are two letters, right? What I'm doing is I'm only comparing the first letter to the second letter, right? And then I'm saying, oh, these are equal. I'm removing it. And I go back and I check this letter to the next letter. I'm not checking this letter to the letter all the way there. So I did realize we could use this, but instead take the first letter and compare it to every single letter in there.
So would I need to do something like this?
So yeah, so change it to J, yes. No. So what you're doing, so if you make it to what it was before, just go back.
Oh, just.
What was it? Yeah. So right now, what you did there, that you didn't do any change. What you need to do is, yeah, so we could use this, but make it that if you see this else if, right? Put this in a while loop, this whole thing.
Oh.
Right? Or do it put it in a for loop for blank. So if we do it in a for loop of like for blank j greater than 0, j plus plus, like j, like, make it in a for loop, right?
I'm doing it in a nested loop, and my for loop's right here. And
okay, let's see.
If.
J less than this length, j plus plus. Okay, that's a good one. So let me let's see. Okay, let me look at the full code from the top then. Replace all. Okay. So that one is removing vowels, I see. Okay, so what you're doing is, okay, you need to create another loop within this loop. If we only care about this one specific thing, you need to make another for loop around this else if, right? What's happening is here, because you're doing multiple things at once to this in this one loop, right?
So would I make a for loop and then an if?
In that for loop, do this if thing.
Oh, okay. So it'd be like
the for, yeah. So the for in j equal to 0, j. I mean, you wouldn't do j. You'd have to do a different letter. I think. You could. Like for in j equal to 0.
Oh, should I do another variable, or does it?
It doesn't matter, because remember, this is within that class. These are this gets into later, but you can have specific ways. The way College Board says that this should be teaches, and the way a lot of teachers do it is different. Right? J, yeah, and then j less than.
Would I keep it the same?
Yeah. So here's what you'd have to do. We aren't done yet. We just we're the same code, but we have to do another thing. What we have to do, no. Make this j a different letter. You're right, make this j a different letter. And then k plus plus. Right? No, that is fine. That can be, wait. Else if, okay. Else if no equals to blank. Okay. No, that's fine. What we need to do is, this. So this is a nested for statement. It's been so long since I've done these. These are important. You'll be doing these on the AP exam. I had a specific question on the AP exam that used a nested for loop. What we need to do is we need to change the increments at many times. So what we do is we did j plus 1, right? Mm-hmm.
Yeah.
And what we need to do is we need to go k and check the other letters. So we go j, check all the letters. If it finds removes, it removes. Or if it finds a unique, it removes. Then we make j1 and we check all the letters. We check all the letters after j. So we do k, else if k is greater than j.
Else if
k is greater than j. And then we need to change the substrings.
So would I change the inside?
Wait. Okay. For and k equal to 0, k less than this. Okay, no. We need to change your for loop. I've done that. It's been so long since I've done this, and yet let me find the exact. Do I have an example? so long since I've done this. Let me find a project where I did this.